Day 10, welcome back. We're going to go through page 4 now. Okay, on number 14, we've got a diagram showing a solid triangular prism. It tells us the prism is made from metal and the density of the metal is 6.6 grams per cubic centimetre. Calculate the mass of the prism. So this is a density, mass and volume question. Okay, so remember your formula triangle. Looks like that. What we've been given is the density. And we want the mass, so we need to know the volume, and we haven't been told the volume. We're going to have to figure that out. So just looking back to what this shape is, this is a prism. So to work out the volume, we do the area of the cross section, and then we multiply by that by the depth that cross section goes back through the shape. Okay, so the cross section on this shape is a triangle. The area of that triangle is 12 times 5, so base times height divided by 2. And that will give us 30. And the volume is then 30 times 15, which is 450 cubic centimetres. Okay, we want the mass, so we need to do density times volume. Everything's in the right units, cubic centimetres, gram per cubic centimetre. So we're just going to multiply those things together. And we get 2,970 grams. And just double check on the question, make sure they didn't want it in kilograms or anything. No, it's in grams, so that's fine. Okay, number 15. Liquid A has a density of 1.42 grams per cubic centimetre. 7 cubic centimetres of liquid A is mixed with 125 cubic centimetres of liquid B to make liquid C. Right, I'm just going to stop there straight away. Just say that liquid C will have a total volume of 132 cubic centimetres. Okay, so we can't mix a certain volume of something else with another volume and get less or more than what it was to begin with. Okay, we won't get into chemical reactions and all that sort of thing. Okay, liquid C has a density of 1.05 grams per cubic centimetre. So we've got the volume and the density of liquid C. Find the density of liquid B. Okay, so first we're going to work out the mass of liquid A. Okay, we have its density and we have its volume. So we can times those together. Okay, so whenever you get a question like this, think about what you've got for each liquid and work out the missing bit of information. So I times those together, I get 9.94 grams. Okay, let's think about liquid C. Again, I said this already, we know its volume, because it's going to be these added together, 132. We know its density, so we can work out its mass. We can work out its volume. We've got its density and we've got, we can work out its mass, but in a minute we'll do that. So its volume is those two things added together. So the mass of C is that volume times its density, 1.05. And that is 138.6. Okay, now that we've got the mass of A and the mass of C, we know that C is the combined liquid. So if we took away the mass of A from this, what we would be left with is the mass of B. Because again, if you combine the mass of two liquids, what you will have is the total mass. Okay, you won't have gained any or lost any. So we're just doing the reverse here. Okay, and that gives us 128.66 grams. Just going to come up here. And we want the density, which is the mass, divided by the volume, We know the volume of liquid B. Is 125, and we get the answer 1.03 grams per cubic centimetre. Okay, try to get used to answering these compound unit questions where they're formed like this. So they like to have these mass density volume questions where they're combining two liquids. They like to have speed, distance, time questions with two legs of a journey, and they're very much tackled in the same way. Find out any missing information for part A, part B, part C, whatever you can find, and then you combine those to find what you're looking for. Okay, last question on the page. We've got a distance time graph. Anna drives 45 miles from her home to a meeting. Here is the travel graph. Anna's meeting lasts for 1 hour. She then drives home at a steady speed of 30 miles per hour with no stops. Okay, so her meeting lasting for 1 hour is not this section here, because that's only half an hour, so this is just a stop on her way. And it's told us it was 45 miles she had to drive, so at this point here, that's when she's got to her meeting. So we need to draw a stop for 1 hour. Now at the moment she's at 2:30, so we need to draw a horizontal line. I'm not going to be able to do this very neatly until 3:30, that's not bad. And then 30 miles per hour all the way home. So that's going to be a straight line, and we need to figure out what time, how long that's going to take. So remember your speed, distance, time. We want to know the time, so we need to do distance divided by speed. So we're doing distance, 45 miles, divided by the speed she's going, 30 miles per hour, and that is 1.5. It's going to take her 1.5 hours, in other words, or 1 hour 30 minutes. Remember, that's not 1 hour 50 minutes. So if she's at 3:30 now, that's going to be 5 o'clock she gets home, so we need a straight line until 5 o'clock. Now obviously you'd use a ruler. In fact, I might be able to do it on here. There we go. And that's what it should look like. Okay, next page, final page on the next video.